Hi, today I'm going to talk about how we're going to migrate and refactor a monolithic Java app into a microservices or eventually a cloud native one. So the reason we want to do that is definitely we want to make everything more agile, right? To adapt to those unpredictable use cases or scenarios is that, for example, I have a traffic surge, I have a sudden business growth, right? From the product development perspective, I always want a faster time to market. But from a higher perspective, we definitely want the right person to do the right job. And from the code base perspective, we want the code base to be modularized, to be reused by as many teams as possible. But from the operational perspective, we definitely want it to be agile and most cost effective. So there are two different kind of microservices refactoring aspect that we need to take into consideration. The first one is if the monolithic application is no web service attached, right? So which is this, and the second one is the monolithic application is with some web services. So for the first one, you really need to think about whether it was the effort that a change and rebuild the code base, right? Adapt to a RESTful or microservices one. Sometimes you can just simply build everything from scratch on the cloud. It will be more cost effective. Or if you want to take the long route, you want to change some of the business logic to a RESTful one. You want to convert the functional based SOAP into an entity based REST interface, and you use the tool called Swagger, right, to catalog the services. So this is one way. And the second option or second aspect you need to take into consideration is those application or monolithic application with a web service, right? So if it's built lately, right, using the modern REST or JMS, probably we have to do is just simply split into a different WAR file and make them into each container and make them containerized, and that's it. And for the second one, right, is the SOA, right, is service-oriented architecture built based on the SOAP and AJB. So that could be this application built like 5-10 years back. So you definitely can find some similarities in between, and find, for example, the CRUD action like very easily convertible to the HTTP-based one. So we have to do it just to re-implement or redo those interfaces. And apart from that, you need to change the object representation from the XML to a JSON one. And if you say that I don't want to do any of them, right, it's too complicated. Yes, it's really complicated. So what you can do is just simply implement some of a third party like RPG or MuleSoft REST proxy, right? So this is the option that you can consider. And the third use case or third type of application is really a simple one, built based on JSP and servlet, right? So what you have to do is just simply add additional layer or add additional domain layer and make the domain layer into a RESTful one, and that's it. So since we've considered how we're going to break the monolithic application into a microservices one, and now let's talk about how we composite and orchestrate those microservices. So usually there are two different frameworks that we can follow. The first one is the Spring Cloud. It's really for Java fans. And the second one is Service Mesh, right? That is based on Istio plus the Kubernetes. So let's look at the Spring Cloud one first, right? So as I mentioned earlier, right, it provides you with all those components that you need inside a microservice architecture, like the gateway, like the authentication authorization server, like the service discovery module, right, like the message queue, like the config server or a centralized config server, or the circuit breaker that is for the resilience. However, the limitation of it is the programming language is only restricted to Java. So if your team, a team skill set, right, is really Java, or you're going to stick to Java for the next 5 to 10 years, feel free to adopt this framework, which is a Spring Cloud. Or alternatively, you want to try something different, right, more open, then you can try the second one, which is the service mesh, right? That comprises of the Kubernetes and Istio, and they complement each other with the function that they don't have. For example, the Kubernetes has the service discovery, and it still has the traffic management capability. And here I will just show you the architecture with a selection of mix of both, right? The Spring Cloud together with the SDO and the Kubernetes. So in terms of the visibilities or the observability or distributed tracing or troubleshooting, we can use this set of tools. And in terms of the traffic management and security, then we can use the SDO native one and also the Prometheus. And in terms of the gateway selection, we can use the SDO ingress gateway, and together with the slews for the distributed tracing and the resilience or Strix, right, for the resilience, the kind of use case. And in terms of the service discovery, then we can use the Kubernetes native one. And in terms of the logging, right, we can use back the ELK stack. And for each of the microservices, we're going to adopt the sidecar model. We're going to put the SDO proxy inside each of the port. And in terms of the DB selection, it's pretty standard, the NoSQL and together with SQL, right? So there is a sample architecture with a mixed selection of both Spring Cloud and the service mesh. And now let's talk about how we're going to make it cloud native. It's just one step away once you have, for example, the Spring framework, right? So you have all the components you need. All you have to do is just select, for example, Azure Cloud, GCP, AWS for the virtual machine. And you can do a lift shift to any of the cloud. And it's going to be a cloud agnostic. However, if you want yourself to get locked in, right? So for example, you are super friendly with GCP and you're going to stick to it for the next 5 to 10 years. Of course, it can slowly or replacing each of the Spring Cloud modules with cloud native one from Google, right? So these are the mapping table that you can refer to. And of course, right, you want to make it most cost effective, right? So you can offload some of the simple services to serverless one, right? So you can make it like event-driven architecture that is leveraging the event that is from the messaging, and also all those like serverless components. For example, you can make the function serverless, you can make the DB serverless, you can make the storage serverless, you can make the big data analytics serverless, right? So basically, the reason we want to use serverless is from the cost perspective. It's all about dollar and cents, right? You only pay when the service is activated. And apart from the messaging and serverless functions, we need the logging as well, because you want every single action, right, to be recorded. So these three constitute the event-driven architecture, or we call it the cloud-native one. Right. So this concludes my explanation and presentation. Hope it's helpful. Thank you.